Hi, it's time for lesson 26. And I'm just wondering, what did you have for breakfast? Every mathematician needs to eat breakfast. So this is my snack, not our breakfast. That was a long time ago. It's 26. It's a blue day. So here we go, solving multi-step equations. All right, sorry, that was rude. Okay. So in math world, there are these series of rules that we like to play by, or things that we want to encourage you to do as you're learning how to do math. And we've got our 8 mathematical practices here. I gave this to you at some points. Should be in your binder, but just want to review a couple of them really quickly here. Today we want to make sense of problems and persevere in solving them. We're going to do some using appropriate tools strategically, and probably look for make use of structure. It's probably the 3 that we're going to be hitting today. Because the more steps there are in a problem, the more ways there are to solve it, and there might be one way that's better than another, but it's not obvious, and it's not just said, hey, solve it this way. Once you get tired of always being told, like, you have to do this problem this way. So I'll even try to demonstrate how some problems where it might look like one way might be the quickest, there might be another way to do it. And I really want to encourage you to be creative in your math solving. As long as you're following the rules, then really you're allowed to solve it in different ways. And the more different ways that you can work through a problem, the better you're going to understand how that thing was all put together and how it plays and all those kinds of things. So I'm going to start with a question here, and that is on a problem that's going to have multiple steps to get to the finish line. The question is, which step should I do first? And I just told you there may be more than one way to get to that answer. It's just one way may be better or quicker or the math of least resistance than something else. And so I want you to do this. I want you to consider the goal of a multi-step equation. Equation's got an equal sign, okay, and it's going to have a variable. So the goal is, whatever that variable is, and I'm just going to use the letter x, the goal is to isolate the variable. I should put this, that or, something equals x, either on the left side or the right side. But to get that x all by itself and everything else to the other side of the equal sign. That's your goal. Once you got there, then you've got your solution. So we got 3 strategies to look at today, and you can do any one in any order. It just depends on how the problem is set up and what might be the most convenient thing to do. And so the 3 are listed there in the book under the examples, but the first one is combine like terms. Combine like terms. That is, there might be something in the problem where you can put 2 things together first before you go and do some other math. So collect all the things that are like each other and put them all into one basket. Okay. Second one will be to use the distributive property. Distributive property is going to come up when there's things inside parentheses and multiplication to be done outside the parentheses with the things inside. So for instance, we had something like 2 times x plus 2. You can simplify that by using the distributive property, and that will turn into 2x plus 4 without any parentheses, and now everything can play out in the open. So that might be an option for you. And the third one is to simplify before you solve. Now, the distributive property is a form of simplifying, and combining like terms is a form of simplifying. So it's just, what do you see? Take a good look at your problem, observe what's going on there, and then choose a path to the answer. Plan a strategy. You're like, I don't know what to do. Well, look for like terms. Are there any like terms? Ask yourself that question. Secondly, are there any parentheses? Is there anything that can be simplified? We've got several things, tools in our pocket, in our tool belt, our mathematical tool belt, that we've been discussing over the last several lessons. We've got combining like terms. We've got how do we deal with parentheses. We've got that we're allowed to rearrange things in an addition problem. Group things together that are like each other. We've got ways of dealing with different signs of things and how we switch those signs. So let's look out for those things today. All right, I'm going to put in one that's a little bit trickier today, and I'm going to even put up a problem and say, which thing would you do first, and give you a few seconds to think about that before we proceed and knock those out. So I'm going to go through 4 different problems up here on the board. What I want you to do is I want you to copy it down, and then you probably hit pause and think about which strategy is going to help you get to the finish line the quickest and most efficiently. Okay, efficiency, efficiency, or simplify, simplify, simplify. Here's our first one. Okay, write this down and then hit pause. And once you hit pause, I want you to think what would be the first thing that you do. That's a minus sign right there. And I want you to say it. I want you to identify the rule or the property that you can use first, as well as saying which strategy that you used. Okay, so what you got? Well, I see that we can combine like terms. There's a 5y and there's a 2y, a negative 2y. So those can be put together. And what's the property for that? I'm looking on my little cheat sheet here, and I think that is the commutative property. I can add and subtract these things in any order, so why don't I just group the y things together first? 3y plus 3. And now I start to undo all the things that have been done to y, and I do PEMDAS in reverse. SAD, MEP, S for subtraction, take away 3 from both sides, and we get 6, and we finish it off by undoing the multiplication by using division. Y equals 2. Is that what you got? You should definitely try these on your own before I work them out on the board. Okay, here comes the next one. Magic. Write it down. Take a look at it. Think about it. Try it. Identify the property that you're using. Hit pause. And then see what I do. Okay, what do you see? See any like terms? Well, I mean, there's a number here and there's a number there, and you could combine them first, but we also have another thing, right? We've got parentheses, so that means distributive property, which is a form of simplification. Now, what do we do first, though? Well, you could add 6 to both sides. That would be okay, but let's do the distributive property first. So I'm going to copy down the stuff that's already there, 8 equals. Do the distributive property, 4 times 3, and 4 times m, minus 6. Okay, distributive property. Next step, what are our strategies? Which one? Combine like terms or simplification. So we're going to use the commutative property again and have 12 minus 6 plus 4m, rearrange those. These parts go together, that makes 6. And then our goal, to get m all by itself. So our goal is going to here, in this case, be m equals, and the answer on this side. So undo what they've done. Reverse PEMDAS, SADMEP, subtract 6 from both sides. That is 2, and finish it off by undoing the multiplication with division. M equals 1/2. Is that what you got? Double check by putting 1/2 back in here and doing the math, seeing if you got that one right. Here comes another one. This one's got one of those caution things, okay, that we've highlighted. common Algebra 1 student error. Do you see it? What's the thing that we said before that Algebra 1 students tend to goof up on? Well, and adults too. Right here. Distributing a negative sign. It's got to go and get multiplied by x and by this -3 or the -3. So there's where we need to be very, very careful. Can we combine like terms yet? Not really, except for this one could go over to the other side. So why don't I do that just to do something different? Let's do that first. Let's add 1 to both sides. Give us this distribution still here, but I've cleaned this bit up a little bit for starters. Okay, how about that? Now, caution. This is 5x, and then we have to distribute that negative sign to both pieces inside the parentheses distribution. Negative x, or we said, what's x all by itself? What number goes in front of it? 1x. And then we distribute that. -3 is a +3 equals 19. Now, what do we got? Can we combine like terms? Yes, we can. These are like terms. 5x minus 1x is only 4x. And then we're undoing everything that has been done to x. We're going to undo the addition with subtraction, or x equals 16, and we're going to undo the multiplication with division. Final answer, x equals 4. Okay, be careful about those negative signs when you're distributing. And here's our special bonus. Let's try to do this in more than one way. Okay? Let's try to answer this in more than one way. I could think of 3 things that I could do first here. Can you think of at least one thing that you would do first? Okay. I can think of 3. Maybe you could only come up with 2. If you came up with 2, that's good. That's really good. How many of you said add 8 to both sides? That might not be the first thing you think of, but you could do that, right? You could add 8 to both sides. What would that look like? Add 8, we get 2 times that equals 18. Okay, so that could have been a step that we take to get to the next stage, right? Yes, that's right. And then finish that one off. Now, what else could you do? You could distribute first, right? That's our second strategy. You could distribute that 2 in there and get 8x minus 6. Now you got minus 8 equals 10. These could be combined, moved over to the other side, finish it off with division. So that would then be combining like terms and then isolating the variable x. So that's another way you can do it. Here's one way that you may not have seen, and that is I noticed that 2 and the 8 and the 10 are all even numbers. They're all even numbers. So watch this. I'm going to do a little simplification first by dividing everything by 2. Okay? This whole thing can be divided by 2 because this is this times this. This can be divided by 2, and this can be divided by 2. So that cancels out, and I'm left with 4x minus 3, and I can drop the parentheses because there's no more multiplication. Minus 4 equals 5. That's kind of cool, isn't it? Now let's run this through and find the answer. -3 minus 4 is -7. I'm going to add 7 to both sides to undo the subtraction. And then we finish it off with division. We get our final answer of x equals 3. I would get x equals 3 in all 3 of those different ways of doing it. But the more ways you can find out to work on a problem, or even just look for the most ridiculous way to do it, it's still, if you can get the same right answer, it really does help the way that you think. So you're using structure, and you're using your rules, and you're using different tools on the same problem to get the same answer. It's really, really good for your brain mathematically. Strategically there, you're going to see more things if you're looking for different ways to solve it. Hope that helps. Pick a strategy. It's a good rule to follow.